So now that we understand how to calculate the quantity of power that's flowing into or out of a device, we want to know which direction is it going. Because of course, if I said, hey, I'm going to have a transaction with your bank account that will involve $1,000, you really care about whether that money is going in or coming out. It makes a big difference. And in the same way, we care about whether a circuit element is absorbing power or whether it's supplying power back to the rest of the circuit. And so here we're going to see how to calculate that. The key is actually the same key that we've been seeing so far this semester, and that is always draw the current direction and the voltage polarity so that the current arrow is pointing into the positive terminal of the voltage. And if it's not, if it's currently pointing into the negative terminal of the voltage, then simply flip either the arrow of the current or the polarity of the voltage. This will of course introduce the necessity for a negative sign into one of those two numbers. But as long as the arrowhead is pointing into the positive sign, everything is going to work out in the next step. Because when you calculate the power, be sure to carry that sign along. And then the power that's calculated will be the power that is absorbed by the circuit element. So absorbed could mean received and then used up, could mean received and stored, but it will be going into the circuit element. So if the arrowhead is pointing into the positive terminal, and the number comes out to be positive, then that element is absorbing power. But if the arrowhead is pointing into the positive terminal and the number is negative, then that element is supplying power. You can see here in equation 6 that if you get a negative amount of energy, negative amount of power that's being absorbed, just flip the sign and then it'll become the power that's being supplied. So for example, in the previous example, we had that there was a 15-volt source that had 0.5 amps flowing into the negative terminal. But if we flip the direction of that current, then we'll introduce a negative sign. That will give us that there are negative 7.5 watts being absorbed by that element. Well, negative watts being absorbed is really the same thing as positive watts being supplied. Now, there are different words that we can use for absorbed. We could say dissipated. We could say lots of different words, but I'll try to be consistent in this class with absorbed, and then 7.5 watts is being supplied. So if you happen to find that you have a circuit that only has one voltage source or one current source, then pretty much that circuit element has to be the thing that is supplying power to the rest of the circuit. If it's not, then there's really nothing else in the circuit that could be supplying power at this point in our lives. You will later on encounter some other things that can supply power, but right now we're just at voltage sources, current sources, and resistors. Resistors can never supply power. They can only absorb power. So the only way that a voltage source or a current source could ever receive or absorb power is if there was another more powerful voltage source or current source that happened to be pushing current back into that source. So you now have enough information to solve the direction of power flow example. Once you get that one done, come back and we'll talk about a couple of really nice shortcuts for working with resistors.